So we know that asthma can be set off by air pollution, but we don't know specifically how that occurs. Let me be a little bit clear. We don't know specifically what air pollutants and what impact they have, because we've always looked at them one air pollutant at a time. So the problem that this is a solution for is our ability to match large databases of air quality and emergency healthcare and put them together. So now we're able to see which air pollutants and what concentrations and what conditions are actually setting up people's asthma bad enough that they call 911. So this didn't just happen. We actually had to get the right pieces of the puzzle together, and they included the Houston Health Department, the Houston Fire Department, obviously, and Rice University. And the three roles that of each of us is the Houston Health Department has its air quality division, which monitors the air quality in our area. And we have a very robust air quality monitoring system in Houston. There's a lot of industry here. The Texas Commission on Environmental Quality, the CDC, and the Houston Health Department have come together, and over the years we've built a very robust system, and we've been collecting that data. The Houston Fire Department has been doing electronic records since the mid-1980s, and so we have a very large data system for EMS records. And so we're able to bring those two records together, those two databases together, and then with the expertise of the statisticians at Rice University, we were able to marry these two systems, which weren't written in similar code, and we were able to marry them and then sort through everything and come up with the correlations that we found. And so each one played a very, very important role. I think one of the key elements of making this successful was, and this is going to sound a little corny, but it was courage on the part of the participants. Because we knew that as we were going into this, and we were going to be looking at air quality, and we were going to be matching it with healthcare outcomes, that we were going to probably find something. That can be very politically charged. Air quality is a real area of contention between politicians and industry, yet we need to be able to see beyond that and do the right thing. And so, getting the health department and the fire department and Rice University to come together and work together, that really wasn't that difficult. We were all neighbors, we've worked together on other things over the years. But to go into something for which there may be huge political backlash took an element of courage. And quite honestly, everybody stepped forward on the first invitation. And there's really no hesitation. But every one of us knew that there's potential backlash down the road for doing this. So when we looked at the data, the thing that struck me was that we were able to find that there was a correlation. And on one hand, I was glad, because if it really exists, we need to know about it. On the other hand, I was disappointed because I just feel bad for all the people who suffer the asthma attacks that they have because of the pollutants in the air. What's really good about it, however, is that we were able to find a connection which nobody had ever made before. And we know that it's real because our database between the air quality and the EMS is so robust. The data tables that we took from are so big that when we found this relationship, we know that it's absolutely real. And what we found when we compared these two databases is that while we looked at many, many, many different air pollutants, fine particulate matter, ozone, you name it, it was a wide range of pollutants that we looked at. What we found was that when you have a 3-day rolling average of ozone, which is elevated, and we were able to predict on the third day what it's going to be based on weather conditions and the previous 2 days' actual readings. And when we do the nighttime readings for NO2 and are therefore able to predict what it's going to be that later on that day, when the ozone and the NO2 are both high on those days, we know that the calls to 911 for asthma exacerbations is statistically significantly higher than on days when it's not. And we also know that there's a seasonal variation with this, and that has to do with the weather patterns and so on and so forth. But with a high degree of certainty, we are now able to predict that today is going to be a tough day for asthmatics. I hope that practically we're going to get one thing, is that a way for us to notify patients who have asthma that you can expect today to be a tough day, which means they need to pay attention to their bodies and what signals their bodies are sending them. And if they start feeling like that, gee whiz, today's starting to feel like a bad day early on, they need to understand, no, it's going to be a bad day. Not only did you get a warning, but now your body's telling you, so you need to act appropriately. You know what to do. You, as the patient who's been dealing with this for many, many years in most cases, you already know what to do. Just don't hesitate. Get ahead of the curve. Take care of yourself. The other thing is for the folks that look out for these patients, and this is going to be really parents and teachers, for them to know that today you need to keep a special eye out and act quickly if it looks like the person you care for is getting in trouble. And then the third thing that I really hope to come out of this is more research. We really don't have the whole picture yet. For example, pollen. We don't know exactly what role pollen plays in all this. Pollen is far more difficult to measure in the same sort of terms as the other pollutants are, but that's another wild card that we need to start digging into to pollen and other pollutants and try and figure out, why so many people are dealing with asthma. Is this something that was preventable? Is there something we're doing in the environment that's actually causing asthma in people who wouldn't have otherwise had it? We don't know the answer to that yet, but we need to search for it.